G'day again. This video is just on friction and more specifically sliding friction. So what is happening when something moves across the ground and what sort of friction is holding in place, well not in place but opposing its direction. So when we have friction we have some surface, and let's just have a block sort of thing, and it's sliding across the ground. It's being pushed along the ground due to some force. What we get is we have some force that's opposing the motion, which is our friction force here. So this is normal force, not normal force, some force here, and you're getting some friction going against it. So just thing to remember, thing to note is that friction always opposes motion. So it goes in the opposite direction to motion. Okay, friction always opposes motion. And through experimentation, it's been found that it's all relative to the normal force and as to how much friction will apply to this situation. And in fact, your friction force is actually equal to some constant mu times n. And when I say constant, not exactly constant, but the mu is a measure of how, I guess, sticky the object and the surface are together. And so you get mu is equal to 0 will be like a perfectly smooth surface. So like something like ice or something like that, really slippery, super slippery. Whereas mu is equal to 1 is something really rough. Something like, you know, rubber on rubber or something like that, like super sticky, super grip. And then everything in between, you know, 0.5, that sort of thing. It's just between 0 and 1 mu, and 0.5 would be something like, I don't know, like say wood on a road or something like that. And so there you go. There's sort of the how it works. So there is your measure of how much friction force you'll get, and we need to know the normal force to be able to figure out how much friction is happening in any given situation. So there we go. Let's just jump straight into an example. So let's have an object. We always like having objects. Slides along a surface. We have a force of, let's just say, 30 newtons. And let's just say, I'm just going to chuck in here 10 kilograms. Sorry, 10 kilogram object, force of 30 newtons, and with mu is equal to 0.2. Let's just say 0.2. Find the acceleration of the object. Okay, so what we have some surface, we have some object, and we have a force pushing it along at 30 newtons. So, and we have 10 kilograms, so 10 kilograms, so that means we have a downwards force of 10 G. We have some upwards force of N, it's our normal force going upwards, and opposing that motion is our friction force here. So we have friction force going there. So there's a diagram of our situation. Now, to be able to find the acceleration of this object, then we need to find out what's going on in the horizontal direction, in other words the I direction here. So there's I direction there, and J direction going up in this way. We need to know what's going in the I direction. We want to know what the total force is in the I direction, because that will tell us the acceleration. Because remember, R equals ma. To be able to find acceleration, we need to know what the force is in this direction. To be able to find out what the force is in this direction, we need to know what the friction force is. To be able to find what the friction force is, we need to know what the normal force is, because friction is equal to mu times the normal force. So, so in these types of questions, I would always take it into two pieces. We'll look at the vertical situation first, and then the horizontal situation second. The reason we did that, like I just said, is because we need to know the normal force first before we can find out what the friction force is there. So let's start the problem. Firstly, let's have a look in the I direction, what's going on. Sorry, J direction. J direction first. And we'll just, each component one at a time, look at what the go is. So in the J direction we have R equals MA. Always start with that. Firstly, R. So our total force. In the positive direction we have N. In the negative direction we have 10G. So N minus 10G is your resultant force. The mass is 10. And the acceleration is, well, is it moving up and down? No, it's not. It's sitting still. It's not doing anything in the vertical direction. So its acceleration is 0. And whenever something is not moving, your R is equal to 0. Solve the equation, you've got N equals 10G. Now, a lot of people on these sorts of questions just go straight to writing N equals 10G, and that's fine, as long as you are sure there's no other, no vertical components. Alright, so if this 30 Newton force was going up on an angle or something like that, then you've got some component in the vertical direction. You need to be really careful. In this case, N is just equal to 10G. Perfect. Now let's have a look at the I direction. I direction. R is equal to MA in the I direction. Therefore, let's look at our resultant force. We have, in the positive direction, we have 30. In the negative direction we have our friction force, and that's equal to mass, which is 10, times acceleration, which we want to know what the acceleration force is. Let's go to solve this. So that's 30 minus, our friction force is mu times N, equals 10A. Therefore, 30 minus, now mu is 0.2. And normal force we worked out up here was 10G equals 10A. Let's have a look at this. This is 30 minus 0.2 times 10, so that's minus 2G equals 10A. Therefore, A is equal to 30 minus 2G over 10. Now remember, G is just 9.8, and so that is your answer. If you need an exact answer, then that's 30 minus 2G. If the question asks for 2 decimal places or something like that, then you would calculate that. So jump on your calculator and figure out what that's equal to. I'm not going to bother doing that. And remember, acceleration meters per second squared. Okay, so that's what we're doing here, figuring out what is going on. So just to reiterate, we wanted to know the acceleration in the horizontal direction. To be able to find acceleration, we need to know what the total force is, the resultant force in this direction. To be able to know that, we need to know what the friction force is. To be able to find the friction force, we need to know what the normal force is, because, where is it? I've lost it. Friction force is equal to mu n, so we need to know the normal first. And so that's why we start with the vertical direction, just to find out what the normal force is. That gives us the friction force, that gives us the resultant force, which gives us the acceleration. And so these questions are all too common. Just remember, like I said, be careful. If there's a force going up here, like 30 newtons at an angle of 20 degrees or whatever, then you have some vertical component here that's pulling it up, and so your normal force will not be equal to 10G. You need to think of that elevator situation. You've got a force slightly pulling it up, that'll affect it. You'll get N plus 30 times sine 20 degrees is equal to, minus 10G is equal to 0. So you need to be careful there. Anyway, that's about sliding friction. Hope that makes sense. Go to some examples, yeah, thank you.